Hey, welcome back to the second part of the lesson dealing with the properties of exponents. So like I said at the end of the last video, we will be doing similar questions, just we will be dealing with exponents that are rational. So if you remember when we did, like back in the day, we did rational expressions. That was like the first half of the second unit, which we didn't finish. Remember, we're gonna have the test after March break. And so I may have gone over this at that point. Again, I don't remember, but I feel like I did. But anyways, I'll go over it again anyways. So yeah, rational obviously is just another word for a fraction. So what we're going to be dealing with are exponents that are fractions. Okay. And again, we dealt with this when we talked about radicals in the quadratic unit, which was the second half of unit 2. Okay. So now how do I get an exponent to be rational? Like how do I get an exponent in there? Well, kind of the inspiration behind it is if I look, I mean, we can use the square root as an example. So say, like square root of 4 is 2, right? Square root of 25 is 5. Like we like these we all know, right? But like if you think about it, if you were to show this notation to like an alien from another planet, or to someone who's never seen mathematics before, again, they'd have no idea what the hell. I mean, they wouldn't know what numbers are, or at least these numbers written this way. And the square root symbol, they wouldn't know what that does. What does it mean? Why are you writing this weird, like, kind of hat over these numbers? So we'll use this to kind of inspire our understanding of how to get a rational exponent. So let's look at let's look at 4. Okay, it's like square root of 4. Now we know, like, I'll write it over here. Like I know it's 2. Okay, but let's try to get at the exponent part of this, because right now when you look at this, you're like, yo, I don't see an exponent. So what are you talking about? Well, so I'm going to write this as 2 squared, correct? Everybody cool with that? Like I haven't made anything up, right? Like these two expressions are equal, okay? So now when I kind of investigate this further and think about it, I'm like, well, like, okay, if this is going to end up looking like this, like how do I get rid of this weird stuff here? Okay. So kind of how we do it mathematically, or when we think about mathematicians and notation, we say, oh, well, okay, I have 2 squared. And if I got rid of the square root, made it a bracket, okay? Like I got to put something in my exponent. Like I need to make an exponent here so that somehow the exponent of the end result is going to be 1, right? Everybody cool with that? So now when you think about it, you're like, well, okay, if I'm gonna actually do this, then I'll be like, okay, so I have 2 squared, right? What I'm going to put here, so the exponent is going to be 1/2. So now what I've done, check it out. I've introduced an exponent that is a fraction. Okay. Now, when I look at this this part here, right, like this, between these exponents, between this power and that power, what am I like? What rule will I be illustrating in terms of simplifying? Well, this will be the power rule, right? So this will be, my base is 2, right? 2, but then 2 times 1/2, which is actually like 2 over 2. What's 2 over 2? Well, that is just 1. So what I've done is I've transformed like the beginning, right? If I look at a root, right? Like we know the end result. It kind of like when I was talking about the zero and negative exponents, right? Like we know the rules, but like what's the messy part in between? Like how do we manipulate square root 4 to get a 2, right? And this is how I do it, okay? Where I introduce this this exponent 1 over 2. So I can do the same thing. Like say we did 36, okay? Well, square root of 36, like we know the answer, but I can write this as 6 squared, right? And then 6 squared, well, what, like the exponent is going to be a half, and then I'm going to get 6 to the 2 over 2, which is just 6 to the power of 1, which is what the answer is, right? Like we know the answer, okay? And I can keep doing this, right? We can do this for any perfect square, right? So like if I have, if we do 49, right? Square root of 49, right? That's the square root of 7 squared. Well, I can write 7 squared in a bracket and to the power of 1/2. And then this becomes 7 to the power of 2 over 2, which is just 7 to the power of 1, which is just equal to 7, which we knew, all right? So that means that when you look at, if I scroll up here for a moment, right, what is the common kind of situation with the exponents? Well, check it out. A square root ends up turning to an exponent that is 1/2, okay? So if I write that out nicely, right, dot, 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 dot. Right, if I have some x squared, again, I don't care what x is, I can write this as x to the power of 1/2. Okay, because again, this is a square root. Now, what do you think will happen? Because I mean, there aren't just square roots, right? Like I can have a cubed root, right? Now, again, here, like we never write the square here because we only, when I just write the one root, you know, this we call a square root, but I can have a cubed root, right? This is a cubed root of x. How can I write that as an exponent? Well, if this was a square root and the 2's in the denominator for the exponent, I can just write it like that. Okay? And again, the same thing applies if you're still following me, right? Like if I do the cubed root of 8, right? Now here, how do I approach this? Well, what did I do here? Here I knew it was 6 squared. I knew this was 7 squared. But like what number multiplied by itself 3 times is 8? Well, hopefully you don't need to like move too far from your screen or get a calculator out. We say, well, okay, like 2 cubed is equal to 8, right? These two are equal. And then what happens? Well, this is 2 cubed to the power of a third, and this equals 2 to the power of 3 over 3, which is just 2, right? And again, this, you know, like we know that the cubed root of 8 is equal to 2, right? Why? 2 times 2 times 2 equals 8, right? 2 cubed equals 8. So that means that, oops, sorry. If I keep going farther down, right, where I have, you know, if I have some x to the nth root, right? So the nth root of x. Now, nth, if you are blessed enough to continue in a career in mathematics, like mathematicians love to use "and" for like a general term that can go on forever. So yeah, so like the nth root is any root. So that means I can write this as x, right, to the power of 1 over n. So the denominator, right, this is the root, okay? If I look here, sorry, right, the denominator is the root. The denominator in my exponent is the root, okay? So, generally speaking, now what we'll have to do is you may be given an expression where you have like some sort of root, you have to change it to an exponent and then do simplifying like we did before, okay? So let's look at a couple just to kind of hopefully wrap our heads around this. So you want to express as a radical and evaluate. So if you remember, like from when we did rational expressions, right? A radical means we want to write as a root, and then evaluate just means find the answer. Okay, like the numerical value. Now, just a reminder, I've said this in class before, those of you who are in IB, or sorry, in ALP, and your destiny is to continue in the IB stream, these questions are ones where you should be able to solve without the use of a calculator, okay? So again, like you can obviously just punch that in once we write it as a radical, but just beware that these are questions that are going to be given to you, or that could be given to you on an IB test or on your final exam, where you're expected to know how to do this with your brain. Okay. So again, this is the fourth root of 10,000. Okay. So again, how do I write this as a radical? Well, it's just going to be 10,000. I'm going to put the little root, and then I'm just going to put a 4 there. Okay. Now again, what number multiplied, and again, when you're thinking about this, right, like this is what number multiplied by itself 4 times is 10,000. Okay. So obviously when you think about it, you're like, well, okay, 10,000, well, 10 squared is 100, 10 cubed is 1,000. So 10 to the power of 4 is going to be 10,000. So the answer, right, is just 10. All right. Now I'm pretty sure I went over how to get, like, if you get to this point here, sorry, I'll just highlight that. If you get to this point here and like, you want to punch it into your calculator, or I think we went over that in class prior to staying home. But again, if you have issues with your calculator work, just let me know, and I can help you out. Okay, same thing down here. Let's do the same thing. I'm going to write it as a root, or sorry, a radical. All right, so this is -8. Okay, now here, okay, be careful, because to the untrained eye, you may think like, you're like, yo, this is impossible, because when I like this does not exist, right? Like I can't have a negative under the square root. Why? Because like both answers give me a positive result, right? -2 times -2 is positive 4. Or 2 times 2 is positive. Here, you're like, negative is illegal. However, it is totally mathematically legal here because of, I'll create some suspense. What makes it mathematically legal for this thing to actually work is the cubed, right? Because if you think about it, can you have a number multiplied by itself 3 times and being negative? Yeah, for sure. Right? So here, right, like the answer is -2. Now again, why is it -2? Well, check it out. -2 times -2 times -2. Well, that's just -2 cubed. And again, like this is going to be a positive times this is a negative. What's a positive times a negative? Negative. This is -8. So I'm allowed to have negatives under a root that is an odd number. All right? Pretty cool, that? Okay, let's continue. Now, I just said that. Now I spoiled the next example. Or maybe it looks like I spoiled it. So let's look at this one. Okay, so now here, negative exponent. So remember, what do I do with negative exponents? Well, I put the base in the denominator. So now I have this. And now my exponent is positive, which makes this 1 over the square root of 49, right? 1 over 7. Okay, super easy. All right. And notice also the 49 is never negative. Like some students kind of mix up, they see a negative exponent and then they'll put a negative in front of the base just because, I don't know. It's just one of those common mistakes. I see a negative exponent, I put a 1 over, everything to that exponent goes in the denominator, and now my exponent is positive, this is positive, and we're good to go. Okay? Now, when we get to this one, check it out. If you stare at this, you're like, yo, this is weird. Or, okay, like, what's weird about it? Or not weird, or different, sorry. Every exponent that was a fraction had a 1 here, but now I have a 2. But don't freak out, right? Just use what you know, your power of exponent knowledge and exponent rules and manipulating these things, right? So here, so I could write this like this, 27, right? Is this okay? Okay. Like how, like what really, like what did I do here? What I did, if I can let you know, I just deconstructed the power rule. Okay. You feel me there? You like all I did is I have 2 over 3, which is, I could write this way because 2 times a third is 2/3. And then now, right, well, this is just, right, the cubed root of 27 squared. Now, what's the cubed root of 27? Well, what number times itself 3 times is 27? Well, it's 3. So 3 squared. And then what is 3 squared? 9. Okay. So again, this part here, I'll just write that in there for those of us, right? Right, the cubed root of 27, right, is what number multiplied by itself 3 times is 27? Well, 3 times 3 times 3, right? That's 9 times 3, which is 27, right? So this is 3 cubed, so it's a perfect cube. Okay? So that means in general, if I may, let me just scroll down here for a sec. In general, right, if I have something like a to the m over n, right, I can write this as a to the 1 over n to the power of m, which is the nth root of a to the power of m. Okay? Cool, sure, yeah, whatever. Hang in there. So next, let's do one, oh man, fractions and fractions. So again, please don't be scared. I know generally people freak out about fractions and stuff, but like really, humans, we've come so far. So fractions shouldn't freak us out. Okay, so again, here are fractions. This is 1 over 4. So this is like the 4th root of 16 over 81. Okay? So now, again, I want to write it like I can do this. The 4th root of 16 over the 4th root of 81. Okay? Now, again, when you look at 16 and 81, you're like, okay, these are going to work out nicely. And like I said, if you're in IB, or you're going to be in IB, understanding what the 4th root of 16 without a calculator isn't that difficult, right? Because you're like, well, what number multiplied by itself 4 times is 16? Well, that's 2, right? 2 times 2 times 2 times 2, which is 2 to the power of 4, that is 16, right? So this numerator is 2. What number multiplied by itself 4 times is 81? 3 times 3 times 3 times 3. That's 3 to the power of 4. That equals 81. So 2 over 3 is my answer. That's it. Okay? Everybody cool with that? Obviously, you cannot answer me in real time. Next, okay, so now similar questions where I will have expressions where I'll have to do a little bit more work in my exponent in terms of simplifying. So here, are my bases the same? X, 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 yes. So that means I can apply rules to them. So here, what I'm going to do, the top is the product rule. So what I do is I add my exponents. So it's going to be x to the power of 2 over 3 plus 2 over 3 all over x to the 1 over 3. Okay? Now this I'll add. So I'm going to have 4 over 3 over x to the 1 over 3. And then now here, this is just the quotient rule where I subtract my exponents. So it'll be x to the 4/3 minus 1/3, which is x to the 3/3, which is just x. And I am done. All right. So again, here, I know at the start of the lesson, I went over like how we introduce exponents that are fractions. But like these questions here, you don't need to have that knowledge. You just got to be able to do the algebra. Okay. So let's move on. Okay. Here I have y and a y. So that's good. The bases are the same. Now, again, just like the one this was before. Here I have a power and a power. So I got to do that first. So this is going to be y to the 2/4 and then y to the negative 2/3. Okay. Now here, 2/4 I can reduce, right? So y to the half and then y to the negative 2/3. And then here, base times base. So this is product rule. So here I have y, I'm going to add their exponents. Now I'm adding a negative, just subtracting. So now here, what I would do is I would just take this exponent here, if you want, like, and just do the subtraction on the side and then add it later. So I have 1/2 minus 2/3. Here I need a common denominator, which hopefully you figure out is 6. So that's going to be 3 minus 4. So it's going to be -1/6. All right. So then y to the power of -1/6, not allowed to have negative exponents, right? Not cool. It's improper. It's impolite. I'm going to write this as 1 over y to the 1/6. And generally, we will write this as a radical. Okay, and that is my simplified version of that. Okay. Okay, so again, we want our final answer to have positive exponents and obviously in written as a radical. All right. This one, same kind of deal. Okay, this whole thing is squared. So before I multiply this part in here, I got to deal with this. So this is going to end up being 5 squared, then x to the 2/2 times 4, and then x to the -1/2. And then now, again, this is going to be 25x times 4x to the -1/2. And then what's 25 times 4? Well, that's 100. And then this is x to the power of 1 minus 1/2. Well, what's 1 minus 1/2? That's just 1/2. So I get x to the power of 1/2. And then I want to write it with the radical. Now, again, just keep in mind that it's only this x is to the power of 1/2. So this 100 is not under a root at all. Like, it's just going to be 100 is outside and then root x. Okay. So that was cool. And then now we'll do some, we'll do a couple of weird ones, and then I'll let you finish them, and then I'll post the solutions you can check. So here I have an issue because I have like a root, square root, but then under a cube or a fourth root. So again, this looks weird, and you're like, how the hell do I simplify this? Well, just, again, if you remember what we did at the start, where we introduced the idea of rational exponents. So here, the key is going to be like work inside out. Okay, so the treasure is x to the power of 5. Okay, now this square root I can write as an exponent, right? What's the exponent? Well, if it's the square root, the exponent is 1/2. Okay, but now I have it under another root. So check it out. What can I do with this root? Well, I can write it also as a bracket to the power of exponent. What's the power? Well, it's the fourth root, so this is going to be to the power of 1/4. So now when you look at this, again, it may look weird, and hopefully you're not scared by it, right? When I look at this is so easy because this is just like a double power rule. So what do I do to get my simplified answer? Just multiply exponents. That's it, right? So this is going to be x to the power of 5 times a half times a quarter, which is just x to the power of 5 over 8. All right? So again, what do? I change my radicals or my roots to exponents that are fractions, and then I'm able to simplify. So this is where that knowledge of how I get rational exponents is important in these kind of weird ones. Okay? So let's look at another one, same kind of deal. This one's a little bit, should be more comfortable. So again, I have like, this is written as a radical to a power. So this, we're going to change into a rational exponent, okay? So I'm going to have x cubed y. Again, remember, work inside out, right? I have this fifth root. So again, how do I write that? I write that as 1/5. But then also this is to the power of what? Well, it's to the power of 10. Okay? So now what do I do when I look at this one here? Right? Like what do I do between this power and this power? If you said multiply them, then you're doing good. Yeah. So this will just become x cubed y to the power. I'll write this as an extra long step just to show you. This is going to be 10 over 5, which is just going to be squared, right? X cubed y. And now here, I'm just going to do the power rule again, right? X, and don't forget this, y has a 1. So up 3 times 2, 6. 1 times 2, 2. Done. All right? So these are the ones where you got to be able to manipulate, move between an expression that has roots, write them as exponents with fractions, and then just use exponent rules to simplify. All right? All right, this will be the last one I do, and then I'm going to ask you to do the last question, and then I'll post the answer to see whether you got it or not. So here, again, you look here, you're like, this, the hell is this, man? A decimal, okay? Okay, so yeah, this is a decimal, not cool. Okay, but can you write this as a fraction? Because like I said, if you're an IB, you may have to solve this question without a calculator. And even if you're not going to go to an IB, right, our brains are powerful tools. So again, what is this? This is 0.2, this is 20%, right? Well, how can I write 20% as a fraction? Well, it's just 20 over 100. And then again, if I reduce this, I can divide it by 10. I get 2 over 10, which is just 1/5. So, right, this negative 32, I can write as to the power of 1/5. So what is this? Well, this is the fifth root of negative 32. Now again, think about it. What number multiplied by itself 5 times is negative 32? Well, it's got to be a small number, right? Because I'm multiplying a number by 5, and it only gets 32. It can't be that big. And if you think about like, when you think about hard drives and like, you know, I mean, we may be dating myself, but like, I remember when, you know, you could buy, you know, a computer that only had like 32 gigs, right? And then they had 64 gigs, and then they had 128, right? So hopefully when you see 32, you're like, well, the answer here is just -2, because -2 times -2 times -2 times -2, 1, 2, 3, 4, 5, this equals -32. So this is my answer. And again, did I use a calculator? Hell no. Okay, it's an insult to my intelligence, and I don't need it. Okay? So your homework from this lesson is kind of, I want you to try this one, and then I will post the solution to it, and you can check whether you got it right or not. Okay, so again, this is a half, this is a quarter, this is a third, this is negative a third, sorry, that's negative a third, and this is a quarter, okay? I'll just write it out in case it is a little sloppy. Even though my decision to write it nicer doesn't really look nicer. Anyways, okay, so try this one. And then I think that's it. Yeah, that's it. Okay, so like I said, try the last example here. I'll post the answer, and then also the homework I'll post, and then obviously please email me whenever you want about any questions or concerns at all. All right. So I hope everyone's doing well, and we will talk to you soon. All right. Take care, everyone. See ya.